Right, let's jump right in. Today, we're all going to become data detectives. Our mission? To crack the code of correlation. We're going to figure out how we can find and then measure all those hidden connections in the world around us. Things like our study habits or even our salaries. So, let's get started with our very first clue. Our whole investigation kicks off with a question I think we've all asked ourselves at some point. Do more hours of studying really lead to better marks? Is there a direct link there? This is our central mystery. It's the first clue in our case. Every good detective needs a case file, and this right here, this is ours. We've got data from 5 friends showing the hours they studied each day and the marks they got. Just look at it. As you go down that hours spent column, from Sujata's 2 hours all the way to Johan's 6, what happens to the marks? They just keep climbing. This is our raw evidence. Okay, but just staring at a table of numbers, it isn't always the best way to spot a pattern, right? So, let's pull out the first tool in our data detective toolkit, the scatter diagram. Because honestly, the first step to really understanding data is to see it.
And making one is actually surprisingly simple. First, we draw our 2 axes. The horizontal one, the x-axis, that's our cause, in this case, study hours. The vertical, y-axis, is our effect, which is the marks. Then we just take each friend's data, like Sujata's 2 hours and 55 marks, and we plot that pair as a single little dot on the graph.
And boom, this is where the magic happens. All of a sudden, that boring table of numbers turns into a really clear picture. The dots line up and form this distinct upward-sloping line. Now the clues are up on the evidence board, and that relationship between studying and marks, it's pretty hard to deny. So we can see a pattern. That's step 1. Now, our next job is to figure out its direction. Is it going up, is it going down, or is it just all over the place? For this, we need our second tool, what I like to call the correlation compass. First up is positive correlation, and this is exactly what we saw with our study data. It's simple. As one thing goes up, the other thing goes up right along with it. A classic example is work experience and salary. Generally speaking, the more years of experience you have, the higher your salary is going to be. They move together in the same direction. Then on the flip side, we have negative correlation. Now, negative doesn't mean it's a bad thing. It just means the 2 variables are moving in opposite directions. As one thing goes up, the other goes down. For instance, think about your intelligence versus the number of silly mistakes you might make. The higher the intelligence, usually the fewer the mistakes. See? Opposite directions. And of course, there's the third option. No correlation at all. This is when the data points on our chart look like they've been thrown there randomly, like confetti. There's no rhyme or reason. The 2 things we're looking at, like say a person's height and their income, just have nothing to do with each other. Okay, so we can see the pattern and we know its direction. But how strong is that connection? Is it a rock-solid link, or is it just a faint little whisper in the data? To answer that, we need our final and most powerful tool, the correlation coefficient, which we just call R. The beauty of R is that it's just so simple. It's one single number that tells us everything we need to know about a straight-line relationship. The sign, whether it's plus or minus, tells us the direction, and how close that number is to 1 or -1 tells us how strong the link is. So if you get a value of +1, that's a perfect positive correlation. It's like all the dots on our chart line up in a perfect, straight, upward-sloping line. It is literally the strongest positive connection you can possibly find. And you can probably guess, -1 is the same thing, just in the other direction. It's a perfect negative correlation, a perfectly straight downward-sloping line. Any number in between, like a +0.8 or a -0.3, just shows a relationship that's not quite so perfect, and the closer that number gets to 0, the weaker the connection is. So, there we have it. Our toolkit is complete. We can see the data, find its direction, and even measure its strength. Case closed, right? Well, not so fast. There's one final twist in our story, a classic trap that even the best data detectives can fall into. And here it is. This is the single most important rule in our entire investigation. It's the golden rule of data analysis, so listen close. Correlation does not imply causality. Just because 2 things are related, it does not mean one is causing the other to happen. This breaks it down perfectly. Correlation just shows that X and Y kind of move together. But causation, that means X is the direct reason Y is happening. Think about this classic example. Ice cream sales are highly correlated with shark attacks. Does that mean eating ice cream causes shark attacks? Of course not. There's a third factor, hot weather, that causes both.
Getting this wrong is how we end up with crazy headlines and really bad decisions.
And just when you think you've got it all figured out, the real world throws you a curveball. Sometimes literally. All of our tools so far have been great for measuring straight-line relationships, but, not all stories follow a straight line. Take stress and performance. If you have too little stress, you're bored, your performance is kind of poor, but if you have way too much stress, you're totally burnt out and your performance tanks. The sweet spot is right there in the middle. This is called a curvilinear relationship, and it's a powerful reminder that the stories data tells are often way more complex than we first think.
So our case might be closed, but really, your investigation is just getting started. You now have the Data Detective's toolkit to see the world in a totally new light. So the next time you see a headline claiming that one thing causes another, you'll know to ask, wait a minute, is that just correlation? What other hidden connections and false causes are hiding in the data you see every single day? The truth is out there, just waiting for a good detective to find it.